Hi, my name is David Adamson. I'm the Executive Chairman of Solstice Gold Corporation. The purpose of this presentation is to provide a technical summary of the Strathy Gold Project, which we recently acquired after an extensive search for projects in the Ontario Archean. A little bit by way of background, my experience is largely focused in Ontario, also partly in the United States, but I started in 1987 in the gold belts of Kirkland Lake and spent most of my time in other gold belts, specifically the Red Lake Greenstone Belt, where I was fortunate to be awarded the Co-Discovery Award Colin Spence Award in 2010 for the discovery of the Bateman gold deposit. So we have a fair amount of collective experience in the gold belts of Ontario. We'd been looking for a significant acquisition, and we feel that Strathy could well be it. I'm going to review it with you in the following slides. This slide summarizes the main features of the project, which we're going to examine in more detail in the subsequent slides. I don't plan to read them all out here, but in summary, the Strathy project has excellent access, roads, rail, utilities, and access to nearby workforces in Sudbury and other areas of the Abitibi. And it benefits from very good geological detailed mapping base done by the Ontario Geological Survey, which is supported by airborne magnetic and electromagnetic survey data. So this allows us to form an excellent base from which to set up exploration programs. This work by the government really demonstrates that gold's associated with major structures, like elsewhere in the Abitibi, especially where they intersect favorable horizons and contain intrusives. In other words, a classic Archean orogenic gold setting. In the following slides, we'll see that while gold's associated with known faults, much of the area contains similar untested structures defined by geophysical data, including EM and partially IP coverage, and supported by detailed gridded digital elevation data. Known mineralization responds well to IP, but IP covers only part of the area of our project, including areas with the best developed gold mineralization to date. The Temagami Greenstone Belt is part of the prolific Abitibi subprovince. This belt was off limits for exploration between 1973 and 1997 due to a legal dispute, which was subsequently resolved. So exploration cycles during that period didn't happen, and that was a time when major advances in technological and geological understanding of gold mineralization were taking place. Prior to that time, and until relatively recently, much of the land was tied up with patents and leases, essentially private land, which tends to limit regional scale exploration. The land position gradually improved, and only recently did a large portion of the highest potential land become available. This land was acquired by industry experts, stakers and prospectors, Perry English and Partners Gravel Ridge, from whom we have optioned the ground and have an option to acquire 100% interest on attractive terms. These two factors, the fact that it was tied up from exploration during a boom in technology and land positions which were difficult to consolidate until recently, combined to make Temagami an unusually underexplored belt in the Abitibi, which is a district known for significant gold deposits. Temagami is about 160 kilometers as the crow flies from the new Côté Gold, which is IAMGOLD Sumitomo mine, which sits in the Swayze belt, approximately 160 kilometers to the northwest. This belt, the Swayze, is another part of the Abitibi that until the Côté discovery had been off the radar screen, and it's our contention Temagami should have equal potential. This is a summary map of the core of the belt derived from Ontario Geological Survey summary maps, and it shows a remarkable cluster of gold deposits, which are the red symbols and the red polygon which encloses them. These gold deposits are clearly clustering in the central part of the belt in the area that's denoted in blue here, which is called the Arsenic Lake assemblage. The commonality of these gold showings is that they tend to be gold plus or minus arsenopyrite plus pyrrhotite plus or minus base metals. So although the clustering of gold showings been noted, no obvious underlying systemic causes to date have been identified. But in this presentation, we provide our own compilation of geological, geophysical, and fault analysis data, which provides, in our view, for the first time, compelling evidence that there's a common system, a common linkage, and a much larger mineralizing system than has been documented to date. The land package controlled by Solstice is outlined in yellow, so you can see we control most of that cluster of gold deposits on the map. Moving on to some of the regional controls which we've identified. This slide, focusing in on the area of the previous slide, shows in yellow widespread and significant historical gold occurrences. If they're circles here, they are grab samples from the Ontario Mineral Assessment Files. If they are squares, labeled boxes, they are drill intercepts, also from historical file data. And you can see that up in the northwest, there are some significant gold intercepts, 4.5 meters of 6.68 grams per ton gold, for instance. In the eastern part of the slide, there's a cluster of red and orange circles there, and that's the Lecky gold deposit, which we control all of the down dip potential on below about 100 meters. The base of this map, the colors, which are sort of orange and yellows, are electromagnetic responses. So the first thing we can see that there's widespread, significant historic gold. The other thing we can see on this map is that there are distinctive patterns defined by the EM responses, basically northwest and north-south trends. The Lecky gold deposit, which is the cluster of points, documents significant near-surface gold associated with a north-south fault. And Solstice controls all the down dip potential on this fault from about approximately 100 meters below surface to depths of well over 1.5 kilometers. So this specific area around the cluster of gold occurrences there will be a focus for us. In the northwest of the area, there's historical IP data, which is the dark colored pattern there, which is trending northeast southwest. And these northeast trending parallel anomalies are parallel to the regional deformation zones. Also geological trends. These IP anomalies have been shown to be associated with significant gold and/or copper gold intercepts, which are labeled on the slide. And they present many targets on our own claims, which have not been drilled to date. The blue outline, I should point out, are patented claims, and the black outline here is the Solstice claims. So patented claims are private land, and we control much of the land surrounding them. Significantly, most of the area of highest priority extending around and both east and west of the known Lecky gold deposit has no IP coverage, but we know up to the northwest that IP is a good predictor of mineralization, both gold and base metal. So from this slide, we can begin to see that the area shown by the EM in orange here is underpinned by intriguing underlying trends which are associated with known significant gold where they've been explored, and also IP anomalies where the IP has been carried out, but that most of the area of our claims has neither IP nor historic exploration work. This slide annotates the main electromagnetic trends in yellow dashed lines, which hints at a connected and much larger system than is currently being described or explored. We can start to layer on linear fault analysis derived from detailed satellite and digital elevation data from the provincial and federal governments of Canada. Just for reference, the Lecky gold deposit area, where we saw the clustering of gold occurrences, is in that circled area there. What is quite striking from this analysis, when this data has only relatively recently become available, is that there are a large number of faults which have not been recognized to date on any known geological map. We can see some of the large northeast southwest trending features, which are the parallel to the deformation zones, and we can see a very large number of north-south features, some of which I'm just pointing out here, including a fault which coincides exactly with the known Lecky fault in the region. So since we know that the Lecky fault is one example of a north-south fault associated with significant gold occurrences, it follows that these other previously unrecognized north-south faults should be attractive targets. In this slide, we've layered on some of the faults that we've been able to extract. In yellow, the north-south sets, which are going to be priority targets for us. In white are the deformation zone parallel faults. And what we can see also on this map is in red are gold occurrences, green are base metal occurrences, and we can see the cluster of gold around this north-south fault set, which is going to continue up to the north and to the south here. We can see that there are other north-south fault sets which hitherto have had no exploration on them and aren't covered by IP. And we can see on the patented claims, this area of inset, that there are previously documented gold veins which have been mapped, and they're associated with these north-south fault structures, which we can see clearly on the digital elevation model on the inset there. So this is a powerful confirmation that north-south faults, where they've been explored, are associated with north-south vein sets, both in that area of the inset and down in the Lecky area. On this slide, we're showing the geological information from the Ontario Geological Survey, mapped at a scale of 1 to 14,000, so a nice detailed map scale. Up in the north part of the region, we can see a ultramafic complex in purple. It's associated with some thick copper gold intercepts, which are documented in the files and which are certainly open for more exploration. It's also associated with later north-south associated gold mineralization up in that northern part of the area there. So we've layered onto here is the fault analysis, which we just covered. Obviously the mapping was done well before the fault analysis, and what we can see down in the south, a couple of marker horizons here in green, which the government mapped, a particular kind of basalts. And you can see that they do not extend to the eastern side of the map, the right-hand side of this slide. And that's because they're clearly truncated by one of the faults that we've identified. This looks like a fairly significant northwest-southeast fault. And that's an important validation, therefore, that these faults are real. Obviously, the geology was done long before we did our fault analysis. And by extension, we would expect the north-south faults in this area to be real faults. We can obviously see in some areas we know they are and associated with gold mineralization here at the Lecky fault system. So we would expect by extension these other north-south fault areas to be important targets for potential mineralization. They've hitherto not been explored or recognized. So these are going to become important targets as we move forward. The other thing the OGS noted was in pink here, there are specific intrusive units up in here, down here, clearly intruding along the structures. This one at the south, north-south, this one here, east-west, along some east-west faults, which we've been able to identify. These porphyries are associated with mineralization at all the known gold occurrences in the camp. It's a sort of a common association in the Abitibi that you get these quartz porphyry dikes. They themselves can be mineralized and carry gold, often associated with gold mineralization in the adjacent wall rocks. We know that's also true at the Lecky gold deposit. So these quartz porphyries are important observations too. They sit in these same structural trends that we've been able to identify, and it's telling us it's all part probably of a system. The Ontario Geological Survey, when they describe these north-south faults, describe them having a very long geological history. They say greater than 1 billion years. That's always good from a gold point of view because long-lived systems, these faults can be reactivated over long periods of time to juice up and have multiple phases of gold mineralization. So those major north-south fault sets we've just labeled as A, B, and C. We've now layered on the IP information, which is obviously trending in a northeast-southwest direction, parallel to the major regional trends, the major deformation zones. So we know gold is associated with north-south structures. We're also very interested in seeing the intersection of these north-south structures with IP, for instance, in these areas. And note that all of this area here has no IP, despite the fact that it contains an important gold occurrence, being a Lecky where there's significant drilling being carried out and it's open down dip. And so it follows that all of this area should really be covered by IP, and that'll be a plan because we know there are existing targets on the existing IP that haven't been drilled. And now we know that there's a framework of faulting which we can layer on top of the fabric. Adding back in then the EM data which is available, we noted earlier on that there was a very curious pattern of EM along various trends, north-south and northwest-southeast, and we can clearly see that the faulting which we've identified independently is associated with those EM trends. So we can now start to link both IP, EM with structure and suggest that this is a common system, has much more potential to be mineralized than just at the known Lecky gold deposit area. So the previous slides really documented a regional scale system which we've linked through fault analysis, EM, IP, and gold showing data to suggest it's much larger than the currently known gold system. We're now going to focus on some of the known targets. We'll obviously develop more as we do additional IP and additional work here, but there are already existing go-to targets which we can talk about. One is obviously down dip of Lecky, because we control the down dip extension of the gold zone from about 100 meters below down to about, well, certainly greater than 1.5 kilometers. Immediately west of that area of drilling, there's an EM response, an EM anomaly that we'll talk about in the existing data. And since Lecky itself is a known strong EM anomaly, a EM response just to its west, outside area, the area of known drilling, is obviously a target for us, and it also lies in one of these nests or sets of north-south structures. We've also just recently acquired a line of alpha IP data which was designed to validate or at least confirm the historical data and extend beyond it. Since we know IP is associated with gold and base metals historically, and most of the key areas not covered, we wanted to test a method. We will show you that, and we'll show you an intriguing target. 4 targets actually that are developed from that new line of data. This slide basically shows those main target areas. So at the eastern side, we see the Lecky down dip area, which we will explore and we'll show a little bit more detail. In the bottom right, there's a schematic from through the deposit. So we see a gold system, which is between 2 and 20% sulfide, and it's between 1 and 15 plus meters thick, that characterizes the Lecky system, so we'll take a look at that. There's an EM anomaly just to the west of the known area of drilling, strong anomaly, which we will certainly want to drill test. There are north-south fault sets crossing EM, which we've described in the previous slides, and there's IP targets which are coming down to the western side of the area here, IP2, IP1, IP3. All of these have previous operators identified drill targets on them but didn't drill them. These will be go-to targets since we know that gold and other mineralization is associated with known IP. And then we're showing also this area of new IP, which we'll get into, and it identifies an interesting looking target at the west end of the slide here. And in the white dotted lines is the IP which we plan to carry out hopefully before the end of the summer season, which will give us a template for new targets and hopefully identify new targets in the key target area, which hasn't itself ever been explored using IP. So first of all, then the Lecky down dip target. We're showing here a section along the red line at the bottom right of the section. So this is it's a long section along the Lecky fault essentially. These lines here are the claim boundaries, so anything between these red lines are on our claims. And we can see that there's a significant gold zone that's been defined, shown in yellow here. That's basically a gold shoot that's dipping to the west on this slide, and has within it some very significant intercepts. So we can see here 7.67 grams over 7.25 meters, down further 5 grams over 17 meters, which in itself includes some significant high-grade intercepts. And we can infer that at depth, 17 grams over 1.1, 5.97 over 4.3, that system probably continues at depth. We're talking about 300 meters below surface, and that the area in between there and there has not been explored. So obviously, since this is on our claims, we will plan to validate the historic data and explore this system down dip. We'll plan to use oriented core, which will give us specific information on the orientation of structures and veins, and that will help us look for more of these features and should be a good template to apply to other structures, which we have shown earlier. We expect there to be a large number of other targets like this. This slide shows the existing IP data which are in the files and existing target areas 1 through 4 here. On the right hand side, we can see specific target recommendations from the geophysical consultant. Historically, none of these have been explored. 1, 2, and 4. 3 had one drill hole on it but didn't reach its target. So these are all extant targets. We plan to drill these. We can see also there's a very large area of no IP data labeled on this slide. And we're also showing the EM anomaly here, which is coming through the slide at this northwest southeast. We think it probably is associated with that fault we showed you truncating the major units earlier. So there's EM trend coming through here in a structure, but there's no IP data. So existing targets in each one of these, significant lengths. Everything's going to dip to the southeast here, so the down dip of these systems will be, or these anomalies will be on our claims. And these northeast trending mineralized systems will be interacting with north-south mineralized systems, and those two intersections or areas of intersection are interesting targets for us. We're also showing the alpha IP. There's a large target here at moderate depth and also 3 at near surface, which are intriguing looking targets and give us a lot of confidence that when we start to fill in the IP going eastwards, we would expect to see additional targets. So looking at the newly acquired line of IP, it's done by Simcoe Geosciences out of Aurora, Ontario. It goes from northeast to southwest, labeled on the slide here. This is the plan portion of the slide at the top. So the line is heading down to the southwest. It's crossing those former IP anomalies, which are shown here and here. So we're validating whether they exist, and we're looking to see if there's any other targets further to the south beyond the previous IP survey. And there's a drill hole which importantly confirms and validates the IP anomaly. So there's a very strong chargeability anomaly at the north end, which has some significant intercepts associated with it. You can see 0.5% copper, 5 meters, 0.6% copper, 7 meters, with some gold, and then specific gold intercepts within these drill holes, 11.3 grams over 1.6 meters, and up here 6.7 grams over 4.5 meters. So this historic drill hole, which is just on our own claims right now, validates the IP. There's an iron formation at the top of the hole, and then there's an ultramafic further down the hole, and it has a strong IP response, which is a chargeability response. What we also see, we didn't know about before, is a very strong chargeability anomaly at the southern end of the line, starting at a depth of about 150 meters, and then some near surface targets developed also. So the theory would be that there are structures that are potentially tapping from a chargeable source at depth. So an important validation of the technique, and also we see for the first time an interesting new target. This is the same section line, but now showing resistivity, so the resistance of the rock mass to electrical current. And there's a very significant difference between the two target areas. The northern one is low resistivity. It's the Net Lake intrusive. It's that intrusive ultramafic body which is intruding along the deformation zone. At the top of the hole, there's iron formation, which you can see in the plan section, the top of the slide here. This is iron formation, and that's related to the intercept at the top of that hole. So there's a very good correlation here between the IP resistivity surveys and the known results, and also the historical data. What this slide also shows is that the important target, the new chargeability target for us in this area, is actually high resistivity, which is obviously contrasting with low resistivity of the Net Lake intrusive. We would normally characterize high resistive targets as granites or potentially silicious rocks, and so we would speculate that there may be a mineralized intrusive body at depth, or in any event, there's something with high chargeability and high resistivity at depth, which forms an important target for us and really helps validate not only this technique, the alpha IP, but leads us to want to obviously fill in the area to the east and help further define this target. So to summarize, hopefully we've been able to demonstrate that there's a coherent, linked system here of much larger scale than just that which is known as the Lecky Gold System and the minor exploration up in the northwest, notwithstanding the fact that both of those have documented significant gold intercepts. We've inherited significant gold intersections on our claims down dip of Lecky, and obviously that will be a key target for us, and we think we understand enough about the structural orientation of those zones to drill them essentially right away. We also have existing targets that have been identified with an IP response that form immediate drill targets. So we plan to extend the IP. We know IP is associated with gold and also copper gold intercepts. We have our new line of IP, which has confirmed the previous existing data, but also identified a very intriguing target at moderate depth and 3 near-surface targets. These are drill-ready targets, essentially. As we extend the IP, we'd expect to understand more about the system. We'll layer on geology through the summer and be ready to go into drill phase for A, targets we already know about, and B, new ones which will generate through our work to come, especially the IP. So it's a very unusual opportunity. We think it's got scale. We know it's got a great location. Infrastructure-wise, there's road, rail, there's utility access, there's a nearby workforce. We know it's part of the prolific Abitibi subprovince, and hopefully we've been able to generate enough information in this presentation to convince you, like we're convinced, that this is a much larger system than currently has been documented, and that's why we're excited to take our next step and explore it and drill it. Thanks very much.